Today we're going to talk about how drugs interact with our bodies through intermolecular forces. But wait, what are intermolecular forces? Here's a quick review.
Molecular forces that occur between the molecules that also make certain substances soluble. These are the ImFs. Hello again, intermolecular forces. So intermolecular forces determine the state of matter. For example, isocene or water. These are the ImFs. Now dipole forces are between polar molecules. Opposite ends attract, and this is the dipole force. Stronger force than thunder falls involving H and O and N. Hydrogen shows its nucleus, leaving the rest gasping for breath. Oh, intermolecular forces that occur between the molecules.
That was a quick review of 2 out of 3 of the van der Waals forces. Hydrogen bonding, which is the strongest van der Waals force, and dipole-dipole forces, which is the second strongest force, but we still have to go over London dispersion forces, which are the weakest of all of the intermolecular forces.
We just find out there is another force. It's called London dispersion force. It's temporary, it's the weakest, it's non-polar, it's amazing because it's instantaneous dipoles. ID bonds, induced dipoles. It's weaker than DD bonds. It is very similar to London dispersion force, but induced dipole has polar molecules. ID bond, it's not induced dipole. It is ionic dipole bond. When an ion and polar molecule interact together, there we have ionic dipole bond.
When it comes to how drugs interact with our bodies, London dispersion forces aren't very important because they are so weak. Hydrogen bonding and dipole-dipole forces are the most common and oftentimes the most important because they allow us to have temporary relationships with drugs. Covalent bonds, because they are so strong, can have detrimental effects on our health or they can have beneficial effects on our health. It all depends on dosage and potency. Whether you take in prescribed opioids, THC, or regular ibuprofen, all of those drugs react in the body through intermolecular forces.
When drugs enter the body, they bind to an enzyme, receptor, or a transporter. The drug needs to have a specific structure in order to fit and react with the protein. For the drug to have an effect in the body, it must be attached to its target. Drugs bind to a protein through electrostatic attractions and intermolecular forces, most commonly hydrogen bonding and dipole-dipole forces. For example, when nicotine is in the bloodstream, it binds with acetylcholine receptor through an electrostatic attraction and covalent bonds. Since covalent bonds are a lot stronger than hydrogen or dipole-dipole forces, the drug will have a more powerful effect on the body. Acetylcholine is a neurotransmitter, so the nicotine affects the brain, and the covalent bonds make a longer lasting effect on the body.
By its definition, a drug receptor interaction is reversible, meaning the drug will have a temporary effect on the body. This applies to medicines like Advil, cough syrup, ibuprofen, basically the common over-the-counter drugs. The drug receptor reaction is essentially an exchange of hydrogen bonds between a drug molecule, surrounding water, and the receptor site. Drugs can become very harmful when they have stronger intermolecular forces. Covalent bonds most often occur between the drug and an enzyme, leading to an irreversible bind. By sharing electrons, which is what happens in a covalent bond, a new molecule is formed. This will result in biological effects that cannot be altered. A good example of negative effects of strong intermolecular forces would be an overdose. Overdoses often have irreversible effects on the body and can result in a toxic state or death. Most drugs do not share electrons with the proteins. Although the strength of covalent bonds between drug and protein can be detrimental to health, it can also be very beneficial. Medicines like penicillin and anti-cancer drugs bond with enzymes for an irreversible effect. These drugs are beneficial to humans for curing and treating different diseases. The drug should be taken with caution because an overdose can still occur and the covalent bonds will alter your body. Potency of a drug is what allows us to take doses of medicine that have covalent forces without being harmed. Potency is a measure of drug's concentration required to generate a particular effect. As you see in the drug receptor equation, D is the drug and R is the receptor. The drug has to bring a conformational change to the receptor in order for the effect to take place. The drug-receptor interaction does not always result in an effect, even if they react because the forces may be too weak.